Hey guys, so in the last lecture we have seen various fuel measurement devices, that is volumetric type and gravimetric type flow meter. So today we are going to study uh, measurement of air consumption. So how much air is consumed, that how we can measure. So measurement of air consumption. So measurement of air consumption. So the air flow meter. So we will measure the air with the help of air flow meter. So let me draw. So this is a surge tank. So in this surge tank, the temperature of the surge tank is measured with the help of thermometer. So suppose this is the thermometer, and here an orifice plate is kept. This is orifice plate, and towards it there is a water manometer to measure the pressure. So how much pressure is there in this surge tank. So this is a manometer. This is a water manometer, and here there is a air intake to the engine. So here the air goes to the engine. So this is the airflow meter. So this airflow meter is used for measurement of air consumption in laboratory. So it consists of this surge tank, which is 400 to 600 times to the displacement volume of the engine, so as to reduce pulsation. So this is 400 to 600 times to the air required in the carburetor. So this helps in reducing the pulsation. So it can give air and it can take air back. So it will reduce the pulsation. So surge tank is connected to the intake side of the engine. So it is connected to the intake side of the engine where air is being intake with a orifice. So here orifice of a cross sectional area A and known discharge coefficient CD. So here we know A and CD. CD is known. So the pressure difference causing the airflow is measured with the help of water manometer. So here PD, pressure difference, is measured with the help of manometer. So let uh, delta HW. So what is delta HW? So this is the difference in the height is called uh, delta H, and W is for water. So that is delta HW with the pressure difference in centimeter of water, and delta H air, the corresponding pressure difference in centimeter of air. So based on unit area of manometer, uh, the head, so what will be the pressure? So as we know, the formula for pressure is rho gh. So we are taking pressure is equal to rho of water into g. So as we are taking in centimeter, so uh, so we will take g as uh, let me keep it as g, and h is delta hw will be equal to rho of air into g into delta h of air. So g gets cancelled. So I want to find, suppose, delta h of air. I have to find delta h of air. So delta h of air, so I'll make it as a subject. So I'll get rho w delta HW divided by rho of air. So rho of W divided by rho of air into delta HW. Now I know the density of water. What is the density of water is 1000. So I can use that as a 1000. And also now the formula for volumetric flow rate of air. Volumetric flow rate of air is CD into A, which we know, coefficient of discharge and area, into under root 2g delta H of air. So this is 2g delta H of air. So here the delta H of air we know, so we'll apply this in this equation. So what we'll get, the volumetric flow rate of air. So V will be equal to CD A into under 2g into rho W delta HW upon rho of air. So this is inside this. So this is the volumetric flow rate of air. Now suppose I want to find the mass flow rate of air. So as we know, the density of air is equal to mass per unit volume. As we know, the formula for density is mass per unit volume. So this is the volume of air. If I want to find the mass of air, so I will get mass of air is equal to volume of air into rho of air. So I will just use this formula of volume of air here. So I will get the mass of air. So I'll get MA is equal to, instead of VA, I will use CD A rho A under root rho, sorry, 2g rho W upon rho A into delta HW. So I will just move this inside rho A. So if a rho A is going inside the square root, so it will just get squared. So I will get CDA into 2g rho A rho W delta HW. So this is the mass flow rate of air, and this is the volumetric flow rate of air. So with the help of this flow meter we can find the volume volume and mass of the air. The next meter is to find the air consumption is viscous airflow meter. So the second is viscous air flow meter. So for accurate measurements of air, a clock viscous airflow meter is used. So this meter uses an element where viscous resistance is the principal source of pressure loss with negligible kinetic effects. Therefore, it gives a linear relationship between the flow and the pressure drop. So let me draw. So suppose suppose here is the air inlet, and here is to the engine. The air is going to the engine. So this is the dry air filter. This is dry air filter, and this is the oil air filter. This is the oil air filter. And the next is, suppose, so this meter uses an element where, as I said, viscous resistance is the principal source of the pressure loss. We will neglect the kinetic effects. So the air is passed to the air filter. So here air is passed to the air filters. So oil air filter and dry air filter. So as to remove any contamination in the air. So the air now passes through the uh, viscous element consisting of very large number of passages in the form of honeycomb. So now it is passing through this honeycomb, and each passage being a triangular size. So the pressure drop is measured with the help of manometer. So here a manometer is kept to measure the pressure drop after passing through the honeycomb. So the felt pads, so these are the felt pads, are fitted in the manometer connections to damp out any fluctuations. So if there are any fluctuations, so it will get damped down. So with the help of this, the air is being measured. Now the next measurement is the measurement of speed. So measurement of speed. So the speed of the engine can be measured with the help of what are the devices? This tachometer. With the help of tachometer, it can be mechanical or electrical, any mechanical counters, timers, stroboscope, electronic pulse counters, etc. However, mechanical electrical tachometers are affected by the temperature variations, and they are not very accurate. So, for accurate and continuous measurement of speed, a magnetic pick up and placed near a two-third wheel coupled to the engine shaft can be used. So the magnetic peak will produce a pulse every revolution, and pulse counter will measure the speed accurately. So this is more accurate. So this is the device used for measurement of speed. Now the next topic is heat balance sheet or energy balance. There is heat balance sheet. Heat balance sheet. So heat balance represent an account of the heat. As you know, as you heard this word balance sheet. In balance sheet, we just measure the money. We balance the money. Then how, where is the money is debited or credited? The same way here, we are going to balance the heat. That how much heat is being generated, dissipated, where it is going. So total heat we need to balance. So heat balance sheet represents an account of the heat supplied in the fuel and released in the combustion and its utilization in the engine. So necessary information concerning the performance of the engine is obtained from the heat balance sheet. So in order to draw heat balance sheet, a complete test on the engine must be carried out while the engine is run at a constant load. So heat supplied. So heat supplied. So heat supplied is calculated as energy supplied to the engine in the form of fuel supplied to the engine. So heat supplied will be equal to mf into Cv. That is mass flow rate of the fuel into calorific value of the fuel. So that is mf into Cv. And heat is released during the combustion. So heat expenditure. So heat expenditure, as we use the word money expenditure, here we will use heat expenditure or utilized. So heat energy of the fuel is partly converted into useful work, to that is brake power, and the remainder is carried out by a cooling water, exhaust gases, and some heat is lost in radiation, incomplete combustion, lubricating oil, which remains unaccounted for. So frictional power is not accounted in the heat calculation, since friction work is converted into heat, which in turn transferred partly to the cooling water and remainder is carried out to the exhaust gases. So calculations for the expenditure of the heat will be A, the heat equivalent to brake power, that is BP, that how much brake power we are getting. So in that also we can get that how much heat is we have used. Then second is heat rejected into the cooling water, so how much it is rejected to the cooling water, so how much the temperature of the cooling water has raised. So with the help of that mcp delta t we can calculate the how much heat has been cooling water has taken. Then heat carried away by the exhaust gases. So here also exhaust gases. So here also we will use the same formula, that is mcp delta t. So here the mass flow rate is considered of a exhaust gases, and that is n plus. So what will be the here mass flow rate of exhaust gas? So here it will be the mass of air plus mass of fuel. So that will be the total mass into Cp, that is specific heat of gas, and temperature of the exhaust gas and room temperature difference. So we will get the heat carried out by the exhaust gases, and then we will prepare a balance sheet. So we'll prepare a table. So heat supplied here on the left hand side, then uh, sorry, so I will just write here, suppose heat supplied, so it will come in kilojoule per minute, then percentage, then heat expenditure, then that is in kilojoule per minute, and then percentage. So heat supplied kilojoule per minute percentage, heat expenditure kilojoule per minute and percentage. So heat supplied is suppose 100%. So here then heat expenditure may be in brake power, then in cooling water, then in exhaust gases, then heat account unaccounted due to radiation, heat unaccounted due to radiation, and then total we should get here 100%, and here total is 100%. So this total should match 100 and 100%. So that is total. So this is the balance sheet, that is we call the heat balance sheet. So this is similar to the money balance sheet, but here instead of money we are just taking account of heat. So I hope you understood this whole balance sheet. Now in the next lecture we will see different variables affecting the engine performance. So what are the variables? There is air fuel ratio, compression ratio, rate of combustion, ignition timing, engine speed, mass of intake of charge and supercharging of engines, and how we can improve the engine performance. So next we will discuss this all topic. So uh, and the next in the next lecture we will also see various SI and CI curves and how they vary. So I hope you understood this all heat balance sheet, what we were taught today, viscous airflow meter and other that is flow meters to measure the air consumption. So hope to see you in the next lecture. So thank you very much.